Okay, so in 6.1, we talked about powers um, and how numbers and variables behave with powers. So what we're going to do is now we're going to talk about the inverses of powers. And the inverse of power is what we call, we use what's called radicals, which is kind of like a square root. So like if I told you that 2 squared equals 4, then the square root of 4 would equal 2. Okay, and if I said 2 cubed equals 8, then the inverse of that would be what we call the cube root of 8, and that would be 2. So basically, we're working backwards from powers. Okay, and we're going to talk more and more about this here in just a second because I know that that's relatively new. But that's kind of a preview into 6.2, which is radicals and rational. So those are two different words, radical and rational, exponents. Okay, so that's what we got going on here. And they're very much related to what we talked about in 6.1. So let's just go with kind of an intro here. If I say that 3 times 3, we say that we can write that as 3 squared, right? And we know that 3 squared is equal to 9. So then we say that 3 is equal to the square root of 9. Okay, that's just kind of working backwards. And so now let's talk about, again, this idea up here. Or if I said, okay, if you have 2 times 2 times 2, that's equal to 2 cubed, which we know, if you use a calculator, is equal to 8. So then working backwards, we can say, okay, well then if we want to work backwards and we want to get to 2, okay, then we can work backwards and say, well, that's like 2 times 2 times 2. And so we say that 2 is equal to the cube root of 8. Okay, so it's just working backwards. And let's do a couple more before we start generalizing it here. Let's say you have 5 times 5 times 5 times 5. Well, that's equivalent to 5 to the power of 4. And so that is equal to 625 if you use that in your calculator. And so we say that 5 is the 4th root of 625. That's what we say there. Okay. So now let's generalize it just a little bit. If we've got b times b times b times b, however many times we've got, and that's equal to some number a, right? Those could be anything. B times b times b times however many times we do it. We're going to call that n times. So it's however many times we're taking that number and multiplying it by itself. We say that b is the nth root of a. Okay, so basically this n here comes from the power that we multiplied with. Okay, so that's helpful. This right here is called a radical sign. It looks like a square root sign, and in normal terms it is, but now we're going to talk about things that aren't just square roots. We're going to talk about cube roots or 4th roots or 5th roots, and so we just generalize this by calling it the radical. Okay, what's underneath here? That's called the radicand, and I will probably use that terminology a little bit here. Okay. So that's the first thing that we need to understand about all this is now we don't just have square roots, we can have cube roots. So it's basically saying what number could you multiply by itself n times, and that's what we call the nth root. Okay, so anyway, we'll revisit those ideas here in just a second. So that's kind of part 1 of the intro. Part 2 of the intro, so that was what we talk about with radicals. Now let's talk about rational exponents. Okay, so first of all, we have to define a rational number. Because if we don't know what a rational number is, then we're not going to understand what a rational exponent is. And a rational number is a number that can be written as a fraction. That's what a rational number is. So an example of a rational number is 2/3. Or we could also say that 3 is a rational number because 3 could be 3 over 1. We just don't normally say the over 1 part. Okay. 5,028 over 16, as ugly as that is a rational number. A rational number is anything that can be written as a fraction. Okay. 1 over 7 is a rational number. Things that are irrational, meaning that they can't be written as a fraction, are like pi. And we haven't gotten to this yet, but Euler's number E is also irrational. I is irrational, okay? So just most of the things that you understand so far have been rational. Some are not, though, okay? So the thing that you need to understand about rational numbers is that they're going to be fractions, all right? So what we're going to be taking now, if we have rational exponents, is we've got fractions in the exponent. Oh boy, this will be fun. Okay, so let's look here at example 1. Okay, in example 1, we're going to do a couple in here. We're going to say 9 to the 1/2. Okay, well, let's say you didn't have any idea whatsoever. We've got this really cool thing called a calculator that'll tell us. So let's take 9 to the power 1/2 and see what it gives us. Oh, it gives us 3. Okay, so we're going to continue that to see if we notice a pattern here. 9 to the 1/2 is 3. Okay, and I'm going to continue something else on this side in just a second, but I want to give you a couple more examples here. What if we did 8 to the 1/3? Okay, so if we did 8 to the 1/3, that's 2. Okay, so again, I'll come back to this in a second. Let's do one more here. If we did 625 to the 1/4, let's see what happens with that. 625 to the 1/4. That gives us 5, okay? All right, so obviously there's going to be a pattern here because I don't expect you to know this off the top of your head. So let's use these here as patterns, okay? So let's just think about how could we get from 9 to 3, thinking about powers or roots, right? Obviously you can divide by 3, but we don't want to be thinking in terms of multiplication or division here. I want to think in terms of powers. Okay, so I know to get to 9 to 3, I could square root 9, right? And I'm going to put a 2 out in front here. Whenever there's not a number out in front, I assume it to be a square, but you can add the 2 if you need to, okay? And a similar thought here with 8 to 2. Well, we just talked about how the cube root of 8 gets us to 2, okay? And for 625 to the 1/4, we get 5. And I'm pretty sure up here we decided that the 4th root of 625 was 5. So that means that we've got the 4th root of 625. Okay, so if you notice, in general here, whatever number was here in the denominator comes out to be the index. So let's write that. In general, the denominator is the same. Now I'm running out of space here. Is the same as the index. So if you've got a rational exponent like this, you can turn it into radical form, and we're going to spend a lot of the second part of this video flip-flopping in between the two things. Okay? All right, so that's a nice pattern, but you're like, well, Ms. Bachman, what about the numerator? Well, okay, let's use what we know here to keep going with this idea. So what if I gave you now something that had a different numerator other than 1? So if I gave you 4 to the 3 halves. Okay, so let's put the puzzle together. First of all, let's see what it is. 4 to the 3 halves is equal to 8. Okay, so we know that that's the answer. We also know from this up here that the denominator has to be the index. Okay, and so we have to think about, okay, well, how in the world are we going to get there? So we've obviously got a 3 we got to deal with, and we've got to deal with this 4. But also you notice up here, whatever number this base was, that was the number that went underneath the radicand. So, or that is the radicand, it's what went underneath the radical. Okay, so obviously the square root of 4 is not 8. So we have to do something here so that We get to 8. Well, we know the square root of 4 is 2. Well, so now we got to get to 8, and we have to use a 3. And if you remember, 2 cubed equaled 8. And if you're ever unsure, here's what you can do. Ready? Square root of 4 cubed. Oh, that got us to 8. Okay, great. And remember, I don't expect you to make these jumps on your own. Okay, the things that I'm showing you here are just patterns that I, as your teacher, am trying to get you to recognize. Okay, let's try another one. So we've got, what if we did 2 to the 4 halves? Okay, now you could reduce that, but just for our purposes here, let's not. Let's take 2 to the 4 halves, which is equal to 4. Okay, so we know that's the answer. That's what we got to get to. We know that the denominator, which is 2, is our index. We know that this is our radicand right there. Okay, and we're like, well, the square root of 2 doesn't make any sense here, but we got to get to 4. So how could we get to, well, if we're going to square root something and get to 4, that means we got to square root 16 to get to 4. So I somehow have to get 2 to be 16. Okay, well, let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so what I think happens is if we take 2 to the 4th, we get 16. And it doesn't matter if that exponent's on the inside or on the outside like this. So now let's see what happens if we take the square root of 2 to the 4th. We get 4, which is what we should have gotten. Okay, good. Let's do one more here before we generalize it. What if I did 16 to the 1/2? Okay, so 16 to the 1/2 is 4. Okay, and I know that this out here comes to be the index, the base becomes the radicand, and I already know that the square root of 16 is 4, so if I put that to the power of 1, it doesn't change anything, right? And like I said, I don't expect you to make these jumps on your own. But are you noticing that if the denominator here comes out to be the index, then the numerator comes out to be a power? Hopefully you see that. Whether you need to rewind that and look at it again, okay, we say in general, okay, the numerator is the same as the exponent. Okay? So now let's talk in general here. Okay? In general, what we can say, this is like the big key here. If you've got some number, we'll just call it b, and it's got a fraction as an exponent, then what you're going to do is that you're going to have a radical. The base becomes the radicand. The denominator becomes your index. And the numerator is the power on all of that. This is the big idea. This is what you have to have, in other words, memorize. You know, I don't love rote memorization with you all. I think it teaches you to be a test taker, not a thinker. But anyway, that's the big idea here. Okay? And so what we're going to do for the rest of the video is just flip-flop between a rational exponent and radical form. Okay? And I want you to make sure you understand the difference in those wordings. Okay? This is with a rational exponent. This is radical form. Okay? For self-explanatory reasons, I would hope. A rational exponent has an exponent. There's a fraction, and a radical form has a radical. Okay, so what we're going to do is I'm going to give you, parts, and we're going to have to fill in the rest. So if I've got something that's in radical form, then I'm going to change it to exponent form, and then we're going to simplify. Okay, so we're basically going to make like a table or a list here. Okay. So let's say that I gave you the square root of 100. That's in radical form. Okay? If you don't see an index, it's assumed to be 2. And if you don't see a power, it's assumed to be 1. Might want to rewind that and listen to the last 5 seconds again because that was important. Okay. So now, so we're given this, we need to go backwards to that. So what's underneath stays the base. So that's 100. The power on the outside is the numerator and the index is the denominator. So that would mean that we have 100 to the 1/2. And then we've got 100 to the 1/2 is 10. And what's awesome about all of this is that it should match up. The square root of 100 is 10. So you can always check your work here. Okay? What if I wanted you to move from the cube root of 64? Okay? Well, the radicand becomes the base. The power, which we don't see it, so we assume it to be 1, becomes the numerator, and the denominator is our index, which is 1/3. And now we can use our calculator. So we do 64 to the 1/3, which is 4. Now I also want to show you how to do this in your calculator. Do you see how there's a 3 as an index on the outside? So to do that, you hit Math, and you can go down here to number 4, and it'll put a 3 there. Okay, and you can check your work that way as well. That turns out to be 4 as well. That's what's cool about this section, is you can check your work. All right, what if I gave you, I'm going to give you something in exponent form this time. If I gave you 9 to the 5/2, okay? So we could plug it in first if we wanted to. 9 to the 5/2 is 243, okay? And now let's put it in radical form. Okay, so the base becomes the radicand. The numerator becomes the power, so that's 5, and then the index becomes the 2. You wouldn't need that 2 if you didn't want it. You could write it as the square root of 9 to the 5th. I would understand it that way. Okay. Okay, well, what if I gave you, in parentheses, the 4th root of 16 cubed? Now, the cool thing about this is those parentheses actually don't matter. I just kind of put them there to just kind of talk about this for a second. It doesn't matter because, like, addition and subtractions are inverses, right? And multiplication and division are inverses. Powers and roots have the same weight in order of operations. So it actually doesn't matter if you 4th root first or if you cube first. You're going to get the same answer. Okay? But nonetheless, the radicand is the base. The power is the numerator. The index is the denominator. So this turns out to be 16 to the 3/4, which is 8. Okay, let's do some more. Let's do a couple more here. What if I gave you 128 to the 1/7? So let's do this side first. We got to have a radical. 128 goes underneath. The numerator becomes my power. The 7 is the index. Now, there's also a way you can plug this into your calculator, okay? If you hit Math, and then you come down here to number 5, do you see how there's an X there in front of the root? That means that we can plug in anything we want. And so then there's a blinking cursor on that box where I can put 7, and then I can plug in 128, and that's 2. I would have also gotten the same thing if I would have done 128 to the 1/7. Okay, so it doesn't matter to me which one you plug in, as long as you get it right. Okay, here's an interesting one. What if I gave you the cube root of -8? So I haven't talked about negatives yet. This is new for us. Okay, so this would be a circumstance in which the negative being paired with the 8 is a close bond. Okay, so when we write this, this would be the same thing as -8. Remember, this is a power of 1 to the power 1/3. And those parentheses are necessary. Okay, because watch. If we do -8 to the 1/3, that gives us a different answer than -8 to the 1/3. Oh, no, it doesn't. Just kidding. So it doesn't actually matter. There's a case when it does matter, but I don't think we're going to run into it in Algebra 1. Okay, if it does pop up, I'll show you here in just a second. Anyway, so we know that this is -2. Okay, so Moral of the story, negatives are going to appear. However, we'll see in just a second how they're not always, you can't always have them. But anyway, we'll get there in a second. Okay. Okay, let's talk about fractions now. What if I gave you the fourth root of 1 over 81? So now I've got fractions and radicals, and oh my gosh. Well, same thing happens. What's underneath stays the base. The power, if we don't see one, is 1, so that's our numerator. And then we've got a denominator of 4. And we can plug that in, parentheses. 1 divided by 81 to the 1/4. And then take that, if you hit, and I know I've said this, but I'm going to say it again. To take that and turn it into a fraction, you hit math, enter, enter. And you get 1/3. So this is equal to 1/3. Okay? Just flip-flopping back and forth. All right, let's do 2 more here. What if I gave you this middle column of -27 to the 1/3? So we come over here, we draw a radical sign. We know that -27 has to be underneath. The numerator is the power. The denominator is the index. Then we can go to our calculator and do -27 to the 1/3, which is -3. Beautiful. Okay. All right, let's talk about one more thing here. All right, let's say that I gave you the square root of 64. Now, before we, start, doing things that we normally need to do, okay, think about it logically. You can't have a square root of -64, right? Because the idea of a square root is you take 2 things, you multiply them together, and then you get that answer. You can't. There's nothing that you can multiply together by itself and get it to -64, right? Because you know that 8 times 8 is positive 64, and -8 times -8 is 64, and yeah, you can say 8 times -8 is -64, but 8 and -8 are not the same number. Okay, so you know that we're running into a problem here, right? If we wanted to change this to exponent form, we could. We could say that this is -64 to the 1/2. But if we try to plug that in, it's going to say error non-real answers. Okay, so that's what you're going to write. You're going to write no real answer or solution. I like solution better. No real solution. Because there's not any number that you could multiply by itself and get it to -64. Okay, so moral of the story, negatives are okay in some cases, but in other cases they're not. And I'm not going to tell you, there's a way that we can generalize that, and maybe you're going to find a pattern when you do your homework. Maybe not. I'm not sure. But that's kind of where we're going with this, is that some things can have negatives and some things can't. Okay, so start the homework. You're probably going to run into some questions, but that's what I'm here for. Okay, see you in class.